Welcome to the electronic version of the CACT Tech Explorer Catapult project developed by the Center for Applied Competitive Technologies at Sierra College. After you've built the Tech Explorer Catapult, you can convert the trigger to an electrical version. The Catapult also has a solar and electronic version. Please follow the written instructions carefully when doing this project, and always remember to wear your safety glasses. This movie assumes that you have already made all the parts of the manual catapult. Start by taking out the printed circuit board. Double-check both the back and the front to be sure that there are no scratches or cuts in the copper traces that carry the current on the board. The side of the board with the printing is the top side, and all parts go on this side. To attach the battery clip connectors to the board, push the battery wires up from the bottom and loop them around in a circle. The red lead is bent 180 degrees and goes into the lower left hole labeled with a plus symbol. The black lead is inserted into the hole marked negative symbol next to the red lead. There are 4 holes available. The first battery clip leads go into the ones on the far left. The next step is to solder the wires. Clean the solder off the iron with the sponge. Apply tinning solder to the tip of the iron. Heat up one of the connections, apply a little bit of solder and wait for it to go fully around the pad, and then take the iron away. Double check that the joint looks shiny and completely circles the pad. Then repeat the process with the next wire connection. Then you will repeat this process with the second battery clip. The order of the wires is red, black, with the final black wire going in the furthest right hole. After you solder the connection for the second battery clip, you can pull down the leads a little bit. Remember to apply solder to the tip of the iron when you're done soldering to prevent oxidation. Look at the instructions to see the picture of the slide switch and find it among your parts. Insert it in the position marked SW2 on the board. Insert the slide switch, turn the board over and lay it on the table to prevent the switch from falling out. Then solder the 3 connections for the switch. As you build this project, follow the periodic test instructions to verify the board is working to that point. The first test determines if the batteries are hooked up correctly and that the switch is working. Temporarily hook up the 2 batteries, turn on the meter and set it to voltage. Measure between the ground pad marked G and D on the board and the 18V at the lower right side of the board. When the switch is on, there should be about 18 volts. There should be no voltage when the switch is turned off. When you know it's working correctly, turn off the meter. Unhook the batteries. They should never be attached when you're working on the board. The next part is an integrated circuit. There are 2 parts that look very similar to each other. It is important that you select the part labeled LM7805. This part is polarity sensitive, so it must be inserted into the board with the metal tab back, without the numbers or writing, facing the outer edge of the board. When you solder the leads, be very careful not to create a solder blob between the leads. Remember to slide the iron up the lead when you're done because it will draw excess solder away from the connection. Also, be careful not to overheat a lead because you could damage the integrated circuit. Once it is soldered, cut the excess lead off, being careful not to cut into the solder. Prevent accidents by turning the board over and cutting toward the table so the cut-off part goes down. Now find your 2.47 UF capacitors. These have a square head and will be inserted at C3 and C4 on the board. You can look at a sample board to double-check the location. Push the capacitor all the way into the board and twist the lead slightly outward so the capacitor won't fall out while you're soldering. When you're done soldering, slide the tip of the iron up the lead to withdraw excess solder. Once the 2 parts are soldered in, cut the leads with the board facing down. Look at your instructions to identify the integrated circuit or IC socket. It is a square part with multiple leads. When it is installed at position U1, the notched line in the socket must line up with the notch printed on the board. Push it down into place and turn over the board. Tweak the leads to keep it from falling out, then solder all the leads in place. To do the next test, put the batteries back in and turn the switch on. You will be measuring between ground marked GND and +5 on the board. The meter should read about 5 volts. The next test is between pin 1 and pin 8 of the IC socket. The red lead goes on pin 1 and the black lead goes on pin 8. You should read about 5 volts on the meter. The push button fire switch is next. It is inserted in SW1 on the board. It fits one of 2 ways, either of which will work. Solder the 4 connections on the back side of the board. Find the 10K ohm resistor. It is marked brown, black, orange, gold. Be careful to find the right resistor because you have several of them and orange looks very similar to red. It goes in R6 on the board. Bend the leads and insert the resistor into the board, leaving the leads to bend slightly outward so it doesn't fall out while soldering. Solder it in place and cut off the excess leads. To do the next test, temporarily attach the batteries in the battery clips and turn on the SW2 switch. The black lead of the meter is attached to ground marked GND and red lead is attached to pin 4 of the integrated circuit or IC socket. The meter should measure about 5 volts. When you press the push button fire switch, the voltage should drop to 0. When you release the switch, the voltage should go back up to 5 volts. When the test is complete, turn off the switch and remove the batteries. Find the 10K resistor, which is brown, black, orange, gold. Again, inspect it carefully because red and orange look very similar to each other. Bend the leads, insert it into position R1 and solder it in place. Point the board down as you clip off the leads. Find the round piezo buzzer by looking at the picture in the instructions. Since it is polarity sensitive, the plus marked on the buzzer must face the plus printed on the circuit board when you insert it into the spot marked Buzz 1. When soldering, remember that the buzzer has an integrated circuit inside, so be careful not to heat it too much. Take off the paper tab. Identify the 3-pin bipolar junction transistor marked 2N4401. It goes in Q1 on the board. The transistor is polarity sensitive and has a flat and a curved side. It is very important to match the flat side of the transistor to the straight line printed on the circuit board. Push it into place, solder it, and cut the leads. For the next test, temporarily attach the batteries and turn on the SW2 switch. With a small jumper wire, touch the ends of the wire to pins 1 and 7 on the IC socket at the same time. You should hear the buzzer. This shows that the buzzer, resistor, and transistor are all working. Doing tests as you work prevents troubleshooting later. If you find a problem during a test, it's easy to identify it and fix it before moving on to the next step. Find the 270 ohm resistor. It is red, violet, brown, gold and goes in R4 on the board. Solder it and trim the leads. Locate the light emitting diode or LED. It is polarity sensitive, so the flat notch above the short lead must line up with the indicator on the board. Insert the LED, solder it, and trim. Begin the next test by attaching the batteries and turning the switch on. With a small jumper wire, connect pins 1 and 2 on the IC socket at the same time. The LED should light up. Turn off the switch and disconnect the batteries. Find the 270 ohm resistor. It is red, violet, brown, gold and goes in R2 on the board. Solder it and trim the leads. Do the same with the 1K ohm resistor R3, which is brown, black, red, gold. Find the opto-isolator by looking at the picture in the instructions. The side with the bevel and the small E on it faces C2 and the power switch. Solder it and trim the leads. To test it, attach the batteries and turn on the switch. Use a jumper wire to touch pins 1 and 5 on the IC socket, and then with the meter, measure the voltage between ground and pin 6. It should read 5 volts. Then, using a scrap of metal, drop it in the slot of the opto-isolator and check that the voltage drops to 0. You can follow the instructions to install the rest of the parts using the same methods as you've seen already. Keep in mind that the large capacitor is polarity sensitive and has the negative lead marked with a stripe. The board has a positive lead hole for the unmarked side of the capacitor. It must be anchored down tightly on the board. You may have to straighten the leads to install it correctly. There are several more resistors to install. Carefully follow the directions and color codes. You will also install 2 diodes that are polarity sensitive. They have band on one side that matches the circuit board. The diodes go in D1 and D2 positions. The remaining large IRL34N transistor has a flat metal tab that faces the center of the board. When you have completed the board, you'll notice that one part is not installed on the space marked RH. All other parts should be in place. Install 2 pieces of 11-inch wire in the location marked solenoid. The wire is brought up through the stress relief hole, looped 180 degrees, and soldered. The other ends have crimp connectors. Inspect your board to be sure that everything is soldered, all wires are trimmed, and that there are no obvious solder bridges connecting 2 pads. To program the chip for the electronic Catapult, you must start the Microchip's MP Lab IDE program on the computer. Once in the Integrated Device program, select Project, then Open. Highlight the Catapult project, then select Open to load the project. The computer screen is now split. The top half of the screen shows the program code in assembly format, and the bottom half shows the output status for operations. Take an unprogrammed chip and plug it into the programming unit. Be very careful to orient pin 1 correctly. On the computer screen, under the Project tab, select Build All to compile the assembly code. In a few seconds, Build Succeeded should appear in the output window. On the computer screen, under the Programmer tab, select Program Device. At the bottom of the screen, you can see it indicates programming. This bottom window describes what functions are being performed. It should say Program Succeeded. This indicates that the device is programmed. You can go back to the Programmer tab and hit Verify Device. The bottom window shows that Verify Succeeded. This means that the program in the laptop has been properly downloaded into the chip. Now remove the chip from the programmer. To test it, place the programmed microcontroller chip into the IC socket in the center of the board. Pin 1 of the chip must match pin 1 of the IC socket. Temporarily hook up batteries and the solenoid with the plunger slightly out. Turn on the circuit board. In a couple of seconds you should hear a beeping sound. Cover up the slot in the opto-isolator with a piece of metal. The LED light should come on, showing that it is armed. The beep should also become more rapid. Press and hold the fire button. The beeping sound should increase, and then the solenoid plunger should pull in. You'll now fabricate and add a vane to the arm. The vane goes in the opto-isolator slot when the Catapult is in the cocked position. Attach the circuit board to the Catapult with mounting screws and 4 spacers that hold it above the base. The wires are routed to the solenoid and attached with crimp connectors. The battery leads snap onto the batteries. Turn on the switch, move the Catapult arm into position, and then push and hold the fire switch until the Catapult releases. Congratulations! You have learned how to follow instructions, identify electronic parts, build a circuit board, and perform periodic tests to complete the electronic catapult.